this one is going to be more on definite integrals. And like I said, I'm just going to do one example because I want to just say, hey, we've done one together in class before you try to do this stuff. Okay. Let's say that we are integrating. All right, it's going to be a definite integral. So let's say our limits of integration are maybe say e and e squared. Okay, we can have e's, we can have pi's, we can have numbers, we can have whatever for our limits of integration. All right, let's suppose we have 1 over x natural log of x dx. Okay, all right, so we've got to integrate like normal here. This is a definite integral, so we got to do our u-substitution. What do we want to let u be? Ooh, what are we going to let u be this time? Anybody want to take a stab? You're all quiet. Like, heck no, I'm not going to guess and be wrong. Are you all awake? I'm going to go look at you. Are you all awake? You are. You're just like, oh, please don't call on me. Don't call on me. Don't call on me. Okay, I won't call on you. Okay.
Natural log of x.
Say what, Dane?
U equals x natural log of x.
Yes, that's what everybody's going to want to do, because what do? We always let the denominator equal the derivative. Okay, but now think ahead. Okay, if I've got x natural log of x, that's going to be a quotient rule. All right, so that's going to be a great big huge derivative. And then what's going to cross out? Nothing's going to cross out. Okay, and matter of fact, we're just going to have a bunch of garbage. Okay, what's the derivative of natural log of x? Do we know the derivative of natural log of x? That should be memorized. That's going to be u prime over u. So it'll be 1 over x. Okay, and I have a 1 over x. All right, but if I take the derivative and I have 1 over x on this side, when I solve for dx, I'm going to have just an x. Okay, that means those x's are going to cross out. So what would have happened had you been doing this on your own? You would have picked x natural log of x, and then you would have got yourself into a mess. All right, and then you would have probably just needed to go back and pick something else for u. Okay, so to avoid the mess, we're just going to go ahead and we're going to let our u equal natural log of x. All right, now once I go through this and you see it, you'll catch it the next time. Okay, derivative of both sides is going to be du here. This derivative u prime over u, right? U prime over u. So 1 over x dx. And then what do? We solve all the way down for our dx, which means I multiply both sides by x. So I have an x du is equal to dx. So even though that derivative was a 1 over x, when I plug it back in, I'm going to have a plain x because I solve all the way down for my dx right there. Okay, now watch how nice and neat this comes up. All right, now I have yet to do this in a written exam for you guys, so you have to remember this, okay? Do my little arrow here, integral. All right, I want to leave off those limits of integration because when I write this, I'm going to have u's, I'm going to have x's. It's going to be horrible. All right, because if we recall from, I don't know, a couple weeks ago, these are limits of integration for x. If I don't have an equation in x, I can't put them there. Okay, so I'm going to keep my 1 over. I'm going to keep the x. I'm going to replace that natural log of x with my u. I'm going to replace dx with x du. All right, this now is going to let those x's cross out. All right, otherwise you would have had a mess. It would not have crossed out. Okay, then I'm going to have the integral of a 1 over u du. Notice I don't have e and e squared in the problem at all because these are limits of integration for x. I'm dealing with u. All right, at this point I can go ahead and take the integral, which would be natural log absolute value of u plus c. All right, when I plug u back in, I then now have it in terms of x. Natural log, absolute value, natural log of x. All right, and now I'm all in terms of x, so I can plug my e and my e squared back in. All right, and remember I did tell you at some point in time we will change those limits of integration. We're not doing it right now, okay? I want more practice like this first. Okay, now when I start plugging in e's, all right, this is where, like, how well did you get through that trig last spring when we were on all that virtual learning? Okay, so what am I going to have here? I'm going to have, don't let me screw this up, natural log, absolute value, natural log of an e squared, all right, minus natural log, absolute value, natural log of an e. All right, plug in the top limit, subtract, plug in the bottom limit. All right, now, like I said, I know that we did trig last year in virtual learning. You got to be able to evaluate that. You've got to be able to evaluate that. All right, there's a shortcut for this. Natural log of e to the second power is going to be, real quick, answer is going to be, I'm having dead silence. That tells me you don't know. All right, or you're too afraid to take a stab. All right, let's go back and do a little bit of trig review here. Okay, so this is the trig stuff that maybe you didn't get good last spring. Okay, natural log, e raised to the second power. All right, now, if I need to, without a calculator, if I need to do this, you got to think about, okay, natural log has a base of e, right? And then I want to evaluate this. So in other words, what does this equal? What does this expression equal? I'm in log form here. I am in log form here. I want to go to exponential form, all right, which means e raised to the x is equal to e squared. So x has to be 2. All right, so there's the algebra behind what this equals. All right, but had we gone through trig good and not in virtual learning, I would have had you last year to the place where you could just look at this and go natural log e squared. Oh, that's 2, because it's going to be that exponent right there. All right, so this equals 2. All right, natural log of e, we've done it. Oh, the room's going dark on me again. Don't go dark on me. All right, natural log of e. Natural log of e is, we've done this enough now today, is 1, right? Same concept. I could do this if I had to. E to what power equals e? It would have to be a 1. Okay, let's do it. I don't want us to not get this part. Natural log of e. All right, if I want to know what that equals, I know the base is e. Well, what does this expression equal? What does it equal? I don't know. E to the x is equal to e. What would x have to be? Imaginary 1 right there. X has to be 1. So natural log of e is 1. Okay. All right, so then there was that, and then there's this. Okay. All right, so what do I have here? I'm going to have natural log of 2 minus the natural log of 1. All right, now natural log of 2, we can't do, all right, but natural log of 1, we've done that enough. Okay, but if not, let's do it just like we did all of these. All right, natural log of 1, I have a base of e, right? Now I'm asking myself, okay, what does this expression equal? Some x, I don't know what it is. E to the x equals 1. Anything raised to the 0 power is 1. Anything raised to the 0 power is 1. So that means natural log of 1 is 0. So this guy is 0. So then my overall answer is natural log of 2. Okay. All right, now the reason I wanted to do that, not that you can't do this part, you can do, well, the u-substitution, that might have been a little tricky. All right, but you can integrate, all right, and you know the concept of a definite integral, plug them in and evaluate, but you've got to be really good at evaluating natural log expressions. Now, granted, when you do your homework, you're going to have your calculator right there, all right, and you're going to plug this stuff in, all right. I want to encourage you to try to think about it first. Think about it, see if you can figure out what they are, and then you do enough of these, you'll have it memorized. Anytime you got e to some exponent, it's going to be the exponent. Anytime you got natural log of e, it's going to be 1. Anytime you have natural log of 1, it's going to be 0. I mean, you will get to where you have them memorized, but right now you probably don't. Okay, so don't rely too heavily on that calculator, because then you're going to not be able to do it if I take the calculator away from you. Okay. All right, so I wanted to just do one example on that, more on that definite integrals, so we could see kind of how that works and we could address some of this trig that we missed last spring in virtual learning. Okay,